Hello everyone. In today's class, I am going to explain 10th class NCERT textbook acids, bases and salts. Chemical properties and other important what is common in all acids and all bases I have already explained in my previous class. In this class, I am going to explain what happens to an acid or a base in water solution. For this, I am going to explain one experimental setup. A test tube is there. I have taken a test tube. In that, I have taken 1 gram of NaCl. Just 1 gram of NaCl common salt I have taken. To this, I fitted with a rubber cork. And then slowly with the dropper, I am adding drop by drop concentrated H₃O4. Whenever I have added concentrated H₃SO4, then what happens? Sodium chloride is there, concentrated H₃SO4 I am adding. Then some vapors are produced. I am sending those vapors. Some vapors are produced. Those vapors I am sending on to the litmus paper. There are two tests. First test is nothing but dry litmus paper, dry blue litmus paper. Second one is moist, nothing but wet blue litmus paper. Let us say in case 1. In case 1, I place a blue litmus paper along these vapors. Now vapors are incidenting on that. In this case, there is no change in color in the experiment. But in the second case, moist or wet blue litmus paper I placed here. So I replaced the first litmus paper and a wet litmus paper I have placed here. Then what happened? Immediately there is a change of color of blue litmus to red color. When blue litmus turns into red color, when there is an acid hits onto this litmus paper, then only it changes to the red in color. So to understand this, first of all, in case 1, what happened? Whenever NaCl react with H₃SO4, before case 1, when NaCl react with H₃SO4, it forms Na2SO4 plus HCl. HCl gas is produced. In case 1, what happened? The dry gas of HCl, we are sending on to the blue litmus paper, which is also dry blue litmus. Whenever dry blue litmus is there, then in this case what happened? No change in color. In case 2, HCl gas, which is also dry gas only, when HCl gas is there, then what happened? I am sending on to the wet, means some moisture is there. So wet blue litmus paper. In that paper, that changes to red in color. So from this experiment, we can observe that this HCl gas does not turn the dry litmus to red. There is no change in color. But this dry HCl gas turns wet blue litmus to red in color. So we can conclude that when HCl is divided into H plus ion in presence of water only. So H plus ions are released in case of water only. It forms H₃O plus and Cl minus ions. Usually HCl can divide it into H plus ions plus Cl minus ions. when this ionization takes place in presence of water, in presence of moisture or in water, HCl can be divided into H plus and Cl minus. Dry HCl gas is not an acid. Why? Because it doesn't produce any H plus ions. But HCl in water produces H plus ions, which is also represented as that H plus and H2O represented as H3O plus. So we can represent acid either H plus or H3O plus. Here one more thing is in the moist, see in this experiment, if any moisture in some coastal areas, humidity is more in the surrounding environment. So whenever humidity is there, moisture in the surrounding environment, then what happened, the surrounding environment moisture is absorbed by the gas, and dry blue litmus also turns to red color. So that's why what happened in those cases, we have to take one tube. This is also called as guarding tube. Guarding tube or drying tube. What it contains? It contains calcium chloride. It contains calcium chloride, solid is there. So contains calcium chloride. So what is the use of calcium chloride? Removes moisture in gas. Moisture in gas. So in external environment consists of moisture. Initially we have to pass this gas to the guarding tube, then we have to release that gas to the litmus paper. So here gas is released, then it is passing through the litmus paper, then this calcium chloride absorbs all the moisture and releases dry HCl gas. This is the importance of guarding tube or drying tube. In examination they may ask you what is the necessity of guarding tube or drying tube. What it contains? It contains calcium chloride. It contains calcium chloride, which removes the moisture in the gas or from the environment. So this is about the, if acid is adding to the NaCl solution, if it is dry gas, it does not produce any H plus ion. That's why there is no change in color. So if there is dry HCl gas is sending on to the wet blue litmus, then what happened? It changes to red color. Why? Because there is an ionization in presence of water takes place, forms the H3O plus. Then only we will have the acidic property. Dry HCl gas is not an acid. HCl gas in presence of moisture is only possesses the acidic property. Similarly, let us see, if acid is dissolved in water, what happened? Just now we have discussed. If base is dissolved in water, if base dissolved in water, nothing but whenever I am adding base to the water, NaOH to the water, then what happened? It releases Na plus plus OH minus ions in presence of water. Usually there is no chemical reaction, just NaOH dissolves. Similarly, KOH also dissolves in water, produce K plus plus OH minus ions. Similarly, magnesium hydroxide also dissolves in water, just like sugar dissolving in water. These are also substances dissolving in water, produces ions Mg2 plus plus OH minus ions. So we have all bases are all producing OH minus ions. So here all acids are producing H plus ions, which is also very important common experiment which expresses all acids produces H plus ions. In case of moisture is there, so all bases produces the OH minus ions. So usually all bases usually consist of OH minus ions. So here we can say that bases generates OH minus ions. So those bases which are soluble means dissolving, like sugar in water, how it is dissolving, like bases which are soluble in water are called Alkalis. Alkali substances are nothing but these are also bases, but which is soluble in water. So all bases does not dissolve in water. These are all important statements I am explaining. Does not dissolve in water. So one more statement is nothing but an alkali is a base. An alkali is a base which dissolves in water. Which dissolves in water. Here all statements bases usually generate produces OH minus. Bases which are soluble in water called as alkalis. All bases does not dissolve in water, but all alkalis are bases which dissolves in water. These four statements are very important in competitive exam point of view also. So now all alkalis, what is the nature of these alkalis? These are soapy to touch. Nothing but if we are rubbing in between our hands, it feels like a very glycerin like we feel like soap is present on our fingers. So bitter in taste. And then corrosive. Corrosive means which is very harmful. If you are placing on your hand, it will feel like very itching, and then you may feel discomfort on your hands. So this is all about the alkalis. So alkalis are also very harmful. You are not supposed to play with them. And one more thing is nothing but here in common we can say that all acids produce H plus ions. Bases produce OH minus ions. So now neutralization takes place. Neutralization reaction takes place in between acid and base. Acid, base react with each other, produce salt and water. How this salt and water is produced? I am taking HCl and then I have taken NaOH. So then here what happened? Here Na reacts with Cl, but H plus ion and OH minus ion react with each other, produce water. So NaCl and then H plus ion, OH minus ion produce the water. H plus OH minus ion forms the H₃O. So this is also very, very important neutralization reaction. Here I wanted to tell you, if a beaker of water is there, slowly we can add drop by drop acid, concentrated acid, HCl or H2SO4. Then what happened? Slowly it is dissolving inside the solution. The mixing of acid to the water is important, which is also exothermic reaction. That is process of dissolving acid or base also. If you are taking NaOH also, NaOH is a solid, to the water is exothermic reaction. Exothermic means heat is evolved. If you hold the beaker, you may feel like heat is produced from the beaker. So the process of dissolving acid or base to the water is an exothermic reaction. Always we have to add drop by drop acid to the water. And otherwise what happens, say for example I have taken pure H2SO4 and slowly just one drop of water I have added to this. Then what happened, it may immediately lot of heat is produced. That is also nothing but exothermic, but which is very much huge heat is produced. Sometimes it breaks the beaker also. Sometimes there is a blasting also takes place in the laboratories. That's why we are not supposed to, this process is not supposed to add. So we are not supposed to add water to the concentrated H2SO4. This process is wrong. We have to add concentrated acid to the water slowly, drop by drop. This is also exothermic. Heat is also evolved, but continuous stirring is required in this case. So whenever we are adding acid or base to the water, whenever we are adding acid or base to the water, then what happened here? Concentration of acid or base decreases. Acid or base decreases. Whenever concentration means ions in concentrated becomes dilute. Concentration of acids or bases decrease. Nothing but ions per unit volume. Per unit volume. What it means? Nothing but initially H plus ions is there. Concentrated means inside the concentrated solution H plus ions are very high. H plus ions are very high. But I am adding drop by drop. Here what happened? H plus ions are here. Then what happened? Per unit volume, concentration of H plus ions, here it is more, but here it is less. So then what happened? Ions per unit volume decreases. Why it is decreases? In case of concentrated solution, per unit volume, more H plus ions are occupied because it is a concentrated. If you are adding acid to the water, then H plus ions are spreading throughout the water slowly. Then what happened? Per unit volume, H plus ion presence is very less. Here it is there, here it is there, here it is there. So per unit volume, number of ions are decreases. This process of decreasing of ions per unit volume is nothing but dilution. Those dilution process involved in acid and bases are involved in dilution process. Those are called as diluted acids or bases. Dilution is nothing but decreasing of ions per unit volume. Decreasing of ions per unit volume I have already explained clearly. So the decrease of volume of ions per unit volume is nothing but dilution. So here acids and bases are involved in dilution. That's why those are called as dilute acids or bases. Means concentrated acids become dilute acids. This is the overall concept and many important statements I have given. Go through the total class. If you have any doubt, ask me in the comment section. Thank you.